All right, they want us to find the tangent and the sine if cosecant is 2 and secant is negative. So cosecant is positive and secant is negative. What does that tell us? What quadrant does that tell us we're in? Cosecant is the reciprocal of? Sine. Sine is positive in the first and second quadrant. Secant is the reciprocal of? Cosine. Cosine is negative.
Tangent's negative.
In the second and third. So we are in the second quadrant. All right, that's what this told us right here. All right, cosecant, I can use a Pythagorean identity to find cotangent. What Pythagorean identity can I use here?
You can use
There's two different things you can do here. They've given us cosecant, which is the reciprocal of sine, and we're trying to find sine. Very quickly.
You can do sine squared theta plus cosine squared theta.
So I can very quickly find one of these answers by reciprocating my cosecant to get sine. Sine is going to be 1/2, right? Fairly simple. Sine is 1/2. I know that much. Then I can either use sine squared plus cosine squared equals 1 to get my cosine and put sine over cosine for my tangent. Or I can use cosecant squared to get cotangent, right? And reciprocate that one. Either Pythagorean identity will work. And so if I do my sine squared plus cosine squared, then I'm going to use 1/2 squared plus cosine squared equals 1. And we're just solving here. Subtract cosine squared of x equals 3/4. So cosine of x is going to be negative square root of 3 over 2, because I know I'm on my second quadrant. How does that help me find my tangent?
You flip it. Or no, not.
Tangent is going to be, tangent is sine over cosine. I'm going to use a quotient identity here, right? So I'm just going to plug in sine over cosine, right? And I end up with negative 1 over square root of 3. We don't want to leave that, so multiply top and bottom by the square root of 3. That means our tangent then is going to be negative square root of 3 over 3. And that then would be my final answer for those two questions there. When I look at something like this with all the different things going on, my first thought is to deal with the left-hand side because it's much more complicated. And when you don't know what to do, like you don't see a Pythagorean identity or anything just obvious in front of you, then change it to all sine and cosine. So cotangent is cosine over sine. Secant is 1 over what? Cosine. And make sure if your secant is squared, your cosine is squared. Tangent then is sine over cosine. Simplify this here. I end up with 1 over sine cosine minus sine over cosine. Get a common denominator, which is sine cosine. So I've got to multiply this. So I have 1 minus sine squared of x over my common denominator of sine cosine. Sine squared of x should look familiar. That's going to make you think of, hopefully, a Pythagorean identity. What is 1 minus sine squared of x? Cosine squared of x, that's a Pythagorean identity that you must have memorized. Cosine squared of x over sine of x, cosine of x. All right, one of those cosines can cancel. You end up with cosine of x over sine of x. Now, if you were simplifying, if I did not have a right-hand side here, your answer would be cotangent. But you are trying to make the left-hand side look like the right-hand side. All right, you're trying to make the left-hand side look like the right-hand side. There are two ways to do this. One, you can simply see that that is cosine of x times 1 over sine of x, which will give you cosine of x times cosecant of x. Let's say you don't see that and you say, oh, well, that is the cotangent. And that's not what you're trying to solve for. You can then take this left-hand side, this right-hand side, and make it into cotangent. So you could say, well, then I'm just going to take cosine of x times my cosecant, rewrite it as sine and cosine. I can see that's cosine of x over sine of x. And then I can see that is also cotangent of x. That also works. So if you don't see this piece down here, but you can simplify this to the same thing you simplified this one to, that also works for verifying that they are the same. If you can simplify them both to the same thing, they are the same. But you do need to show me all of your work for both sides. Don't, at this point, like if you got to here, don't just like say, oh yeah, that's the same. You have not shown me it's the same yet. You need to either show me all of these steps or you need to show me these right here. So understand when it says simplify or verify, you are not giving me a pi over 2, pi over 3 answer. You're just simplifying it to make it look like the other side or verifying it, whatever. When you have an equation like this, where you have numbers involved and all this going on, you're actually going to, it says solve the equation for an actual answer. Your answer should be an angle of some sort in terms of radians. It did specify from 0 to 2 pi. Less than 2 pi, meaning your answer should never be 2 pi. So 0 and 2 pi are the same answer. So your answer should be from 0 up until 2 pi. All right. So in something like this, I am going to try to get everything to one side. All right. And so personally, I try to keep my squares, which is going to be like, for example, if this completely throws you off to get to like the factoring, you can think of this as 2x squared x 4x squared, right? You can think of it in terms of that if you want to, until you get to the factoring. And so if I were to do that, I would subtract my 2x squared over, subtract my x over, and I would have 0 equals 2x squared minus x minus 1, right? And then I can factor that to be 2x plus 1, x minus 1. And you can see then that like 2x times x is 2x squared, 2x is negative 2x, positive x is negative x, and then, so this is my factoring, all right? This is my factoring for this guy. And then you can go back and you can replace all of your x's with just signs. All right, so you have 2 sine of x plus 1, or theta rather. They've given me theta, not x. So 2 sine of theta plus 1 sine of theta minus 1. And so if your factoring throws you off on these, just think of it as a trinomial with a variable. All right. And then, of course, you're going to set each one of these equal to 0. So we are looking for where my sine of theta is negative 1/2 and where my sine of theta is positive 1. All right, negative 1/2, that happens at 30 degree or pi over 6s, and it's going to happen in the third and fourth quadrant. All right, my pi over 6 is in my third and fourth quadrant, which should be my 7 pi over 6 and my 11 pi over 6. That's where your sine is going to be negative 1/2. My sine is positive 1 at only one spot on my unit circle. That's at pi over 2. And so that is my final answer here. I chose 2 that were condensing, but when you're expanding, your goal is to pick 2 angles on the unit circle. And by what I mean by on the unit circle is one of your standard angles that you know the sine and cosine of on the unit circle that add up or subtract to the angle that I have given you. So some of you chose 2 numbers that added up to the number, but they weren't on the unit circle. So that helps you absolutely none. And some of you chose 2 that didn't add up to the number. So they must add up to the number that I've given you, and they must both be one of your standard angles on the unit circle. All right, that's what's important here. But I had more people miss these where we're just condensing. Think of it as expanding and condensing. Expanding is when you've been given an angle and you need to break it up into 2 angles. Condensing is when you've been given the 2 angles and you're condensing it into 1. All right, and so for this one, sine, cosine, cosine, sine. Which of your 3 trig sum and difference identity functions is sine, cosine, cosine, sine?
Sine.
It's your sine. So I know that this is going to be my sine function, and it is plus. My sine follows the plus sign, right? If this is plus, then my sine is going to be plus. For cosine, it's opposite. This is my A, and this is my B. So I can condense this entire thing into sine of pi over 18 plus pi over 9. All right? For your tangent, which some of y'all just completely lost your mind on your quiz, but for your tangent, that entire tangent condenses to the tangent of A plus the tangent of B. And then just give me the tangent, okay? And so here you need a common denominator, of course, being 18. So this is going to be 2 over 18. This is the sine of 3 pi over 18, which is the sine of pi over 6. That is a 30-degree angle, so that is 1/2. All right, the next one. Same concept. Cosine, cosine, sine, sine. Which trig function is this? Cosine. This is a subtraction. My cosine's opposite. So I'm going to say this is my A, this is my B. This is going to be A plus B. My final answer here is just the cosine of 8x. All right, so for this one, they want cosine of 2 theta. Specifically, your original theta is in the first quadrant, all right? And they want the cosine of that double angle, all right? And so if I'm in the first quadrant and I double the angle, what quadrant am I going to end up in? If I start between 0 and 90, I can double this. Double of 0. The very minimum it would be that. The very maximum it would be that, right? So what quadrant am I going to end up in? The second quadrant, right? All right. And so I know I could possibly end up in the first quadrant if I was, below 45. But this one actually ends up in the second quadrant here. So I'm going to replace this cosine of 2 theta with something. So what are my options for cosine of 2 theta? I have 3 options, don't I? What are they?
1 minus 2 sine squared.
Mm-hmm.
2 cosine squared minus 1.
Now, which is the easiest one to use here? 2 cosine squared minus 1. I don't have to solve anything else to use that one. Now, if this had been sine, I must solve for cosine because the only sine option is 2 sine cosine, right? But because this is cosine, I can actually use this one. And I can say, well, the cosine of 2 theta should be 2 cosine squared. They've already given me the cosine, right? Minus 1. And so just do order of operations here. 3/5 squared is what? 9 over 25. We get 18 over 25 minus 25 over 25, right?
7.
Negative 7 over 25.
Feel ready?
All right. Literally work out either sine of 2x or the sine squared cosine. Whichever side of this you find more intimidating, I guess, is fine. Honestly, it's just how you see it. So I know that I need to either get rid of the sine of 2x or have a 2x on the left-hand side. So visually, if I were to do this, I would say, well, that's like sine of x times 2 sine of x cosine of x. Like that's the first thing I see here because I noticed sine and cosine there butted together. 2 sine cosine is sine of 2x. And then if I know what I'm moving towards because it told me I'm moving towards cosecant. Well, sine, right, is 1 over cosecant. And so I end up with sine of 2x over cosine of x, which is what I'm trying to do. Now, let's say you didn't see that, all right? You can then look at the right-hand side. So let's say I took the right-hand side, I would rewrite this sine of 2x, right? And I would make it 2 sine of x cosine of x over cosecant of x. And then I would rewrite this guy, 2 sine of x cosine of x over 1 over sine of x, 1 over sine of x. Keep change flip, so you get 2 sine of x cosine of x times the reciprocal, which is just sine of x. And then, of course, I end up with these two multiplied, so I have 2 sine squared of x cosine of x. Again, that looks like the left-hand side. So either one of these, you could have worked one or the other one out and ended up with the right-hand side or the left-hand side, depending on which one you did. You only have to do one of those. You only have to either show that the left-hand side looks like the right-hand side or that the right-hand side looks like the left-hand side. But that's showing you either way that you start working this out, it's going to work.
Honey, here's your book back.
We have one book.
I gave it to her.
So the goal of the half angle is that you rewrite the angle I've given you in terms of some angle you know divided by 2. Okay, so I don't know 75. 75 is not on my unit circle, but what is on my unit circle?
25 and 50. No.
150. And so I can write 75 is the same thing as 150 divided by 2. So I am now going to say the tangent of 150 divided by 2. And I actually have a formula for this one. What is my formula for my half angle tangent?
Tangent divided by 2
It
equals
is
like 4 different things.
Do the
Let's do 10.
1 minus cosine of 150, right? Over sine of
Wait,
150.
that's not the
No.
tangent.
That's not the easiest one to remember because it's your sine over cosine, right? So I mean, you can try to memorize all of them, but honestly, just remember your sine, cosine, and sine over cosine instead of trying to learn 3 different ones for that one. All right. And so for this one, cosine of 150. 150 is just a 30-degree angle, right, in my second quadrant, right? The cosine of a 30-degree angle is what? Square root of 3 over 2. And in the second quadrant, it is specifically negative square root of 3 over 2. All right? This positive and negative has to do with where this is. What quadrant is this in? 75. What quadrant is 75 in? It's in the first quadrant. So am I going to use my positive or my negative here? Positive. So I can just leave that off. And I'm going to say 1 minus negative square root of 3 over 2 over 1 plus negative square root of 3 over 2. Simplify a little bit here. 1 plus square root of 3 over 2 over 1 minus the square root of 3 over 2. Get some common denominators going on there. So common denominator is going to be 2. So I end up with 2 plus the square root of 3 over 2. 2 minus the square root of 3 over 2. What happens here when I keep change flip? My denominators cancel. All right. And then I'm just going to rationalize this guy right here. All right. So I'm going to say 2 plus the square root of 3. 2 plus the square root of 3. So on the bottom, you get this one squared, which is 4, minus this one squared, which is 3. So you end up with 1. So we don't have to worry about it. On the top, we get the square root of 2 plus the square root of 3, basically squared, right? I mean, isn't that what that is? 2 plus the square root of 3? 2 plus the square root of 3? When I'm multiplying something by itself, it is squared. What happens when I square a square root? You get what is inside.